Okay, so let's start the show here. This is a repeat from yesterday, so I'm not sure if I'm going to post this recording or not, but I'm recording it anyways, just in case there's something new I'm going to say. Right off the bat, I'm just going to tell you that I'm happy to see your work. You're watching the videos, which is the crucial thing for performing the labs. And I can just see the effects of that. All right. And I'm also happy to see that your documentation is pretty much looking like if I may say this word, professionally done documentation. Okay. One little thing that if I might point out, I know you're used to whenever you're going to school right now, you're used to preparing the lab documentation, labs paperwork, as far as preparing it as documentation for the purpose of school-related labs. So I noticed that some of us are still listing the tools in the materials used. What I'm trying to do, what I'm doing here is I'm trying to give you the documentation the way it is going to look like when you go to work. Okay, so when you develop proper habits, it's just going to be that much easier for you you know to find yourself in the real world environment. Our documentation is in a paper form because that's the easiest way to learn. When it comes to filling out the deliverables in today's industry, quite often you're going to see apps. You're going to see phone apps or on the tablets or something like that, and you'll be requested to fill those out and put in the pictures. When I request the pictures for you to take the pictures, the reason is not just one is for the labs purposes, but the other thing is that when you go to work and you go to any kind of installation or service call or anything that has to do with with this industry, with the way you have to work, you are going to be requested to provide pictures. Right? Yeah, I'm happy to see that your work is beginning to look like a professionally prepared documentation. All right. So, okay. Enough of this. Yeah. So when I said that I can see that people are listing the tools that are being used in the list of materials, try not to list the tools that you have used, a couple of screwdrivers or side cutters or pliers or things like that. We don't list those in the list of materials. The purpose of the list of materials in the documentation is for the people who are receiving that documentation and processing that, so they know what materials are supposed to be billed to the client. Okay, so that's just the billable materials. Right? So that, and sometimes we might want to try to be more clear on things. So when you're handwriting, while you're doing your handwriting, just make sure that your writing is clear and readable by somebody else. Okay. As far as the work description, yeah, I can see a lot of point form type of communication there. That's good. Just a point form. You don't have to write a story. I purposely gave you very little space to write, so you can just condense your actions. Did this, period. Did that, period. Did the other thing, period. All right. Cat 5e, patch cable terminated. All right. That's it. Now, the other thing is that when you go in service, when you do service calls, so that will be the installations and things like that. But sometimes it's a very commonly used form in service calls. So when you go to, usually you go for a service call is because something wrong is happening with the equipment. So that's, the client makes a phone call and somebody gets dispatched to address the situation. So a very common thing that is going to make you really good when you use that form is divide the work description into two sections. One, you can just say problem found, colon, and they can just say that something was broken, something wasn't displaying, something whatever, you know, and then just point form, just short descriptions. Problem found, da 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 da, and underneath that, action taken, colon, and then you describe what you did. It's also it's a very good form of communicating when it comes to work orders and deliverables communication. Okay. All right. So this is the last. Yeah. So this is a repeat. So the of from yesterday. So yesterday's video is already posted, and this is going to probably be the reference for our learning materials as far as that goes. But we have a class scheduled today, so we're going to conduct the class. All right. So this was the last slide that we stopped at last time. This table that is already, you have that in your posted lecture notes. Out of all the things that I was talking about, I want you to keep everything and refer back to it when you go to work. But this, when it comes to cabling industry, or infrastructure industry, this is the table you might want to keep and refer to, you know, especially when it comes to using the differences between Cat5e right here and Cat6. As you can see, for example, Cat5e is capable of speed transfer, which is the digital communication, and the bandwidth of 100 megahertz or 1 gigabit per second when it comes to digital transfer speed. Right? So this is the communication between the PC or whatever smart device, such as wireless access point or a cash register, which is basically a PC, or VoIP telephone, things like that. So that's the top speed that the cable can actually handle. All right. And it's pretty much most of them, the longest distance is 300 feet, except for some situations there's a shorter distance. So when you look at the Cat5e, you can have 1 gigabit per second, and you can take it up to 300 feet. It's actually 328, but first of all, 300 is easier to remember, and it's a good idea, good practice to have it no more than 300 feet end to end. So from the jack in the wall to the jack that is in the patch panel, no more than 300 feet, because you still have to use the patch cables to connect the jack to the equipment, whatever it is, and that basically has some feet in it, some distance, and then there's a patch cord that is at the rack location. So those distances all add up. So you get a bit of a headroom when you have a 300 feet. Okay. Now, when it comes to Cat6, you can have up to 10 gigabytes. Right, of transfer speed, so 10 times more, but only until up to 180 feet. If it's more than 180 feet end-to-end link, then you're falling back onto the Cat5e specifications. Right? So it's 1 gigabit per second. So if you're designing a system and client wants Cat6 because Cat6 is better, and yes, of course, well, better, right? In which ways? It is capable of more things. Right? Speed is the thing, the most thing. And if you're going to find out that most of the runs are going to be 200, 250 feet or something like that, then you can just tell the client that, look, you're paying 3 times as much for something that you're not going to get. Right? So if this distance is 250 feet and somebody wants Cat6 installed, it just doesn't make sense, because you might as well get Cat5e, pay less for it, and you're going to get exactly the same thing, because Cat6 won't be able to relay the information with that speed over 180 feet. If the distance is longer than 180 feet. If you want to get full 300 feet at 10 gigabits per second, then you might want to consider Cat6a, which is way more money for just the cable itself, plus all the other paraphernalia, because then you have to get the jacks in the wall that are supposed to be fulfilling the Cat6a specifications, and then you're going to have to get the patch panel that also is able to fulfill the the Cat6a specifications. It costs more money, right? So it depends. So this will help you to design better systems, and you will know what you're talking about when you're designing systems or when you're troubleshooting systems. All right, so this is the next slide that I didn't cover last time, and I did not want to rush through it. All right, so let's just take a look at some of that stuff. This is the modular plug, RJ45. Well, technically, it's not supposed to be called RJ45 because RJ45 is supposed to be the female version of a jack. All right, but very popularly, quite popularly, it is going to be called RJ45. So just don't be technical when you're talking about someone. Yes, be technical, but don't be what do you call it? Smart aleck when it comes to that. RJ45 plug. That is the plug that is going to fulfill the RJ45 jack, which RJ stands for registered jack. So obviously this is not a jack, this is a plug. Right, now the pins. If you're looking at the plug itself, you're counting the pins from left to right. If you're looking at from this side, prongs away from you, and the clip facing down. So 1, 2, 3, 4, 5, 6, 7, 8. You're going to count it from left to right, and these are the numbers of the pins. So sometimes when you're going to look at the color code and the wire mapping sticker that is on the individual jack that you're going to punch, then those numbers, they mean those pin numbers. Okay. Now, when it comes to counting pairs, there are two ways of counting pairs, because this is how we terminate the pairs. What do we have for pairs? We have a blue pair, first five colors of the 25 pair: blue, orange, green, brown, slate. Now we don't have 5 pairs on this plug. We're going to have only 4 pairs, so it's going to be blue, orange, green, and brown. All right, and now there are 2 ways of understanding the pair distribution. One is the USOC version, Universal Order Service Code, USOC, Universal Service Ordering Code. Okay, that's mostly for the telephony and the control systems. Now, when it comes to wiring jacks for Ethernet, we are talking about T568 standard, and you can have A or you can have B. All right. Now, the only difference between having A and B is that you are making while you're counting the pairs in A configuration, you're counting the pairs as they are: blue, orange, green, brown. When it comes to B, you are switching the oranges and the greens. So it's going to be blue, green, orange, brown pairs, okay? And of course, the cables that we're using, they're using the first 4 colors of the 25 pair color code. And the group is white. So you're going to have white, blue, white, orange, white, green, and white, brown. There we go. All right, so so this is the pinout of the T568. Now, the difference between wiring in USOC and wiring T568 is this. Pair number 1 is always the 2 middle prongs. As it's here, see that's blue pair? These are the 2 middle prongs, and they correspond to 4 and 5, pins 4 and 5, because these are the 2 middle prongs. That's always pair 1. That goes in the telephony, that goes in data. Pair 1 is the 2 middle prongs. Pair number 2 is also the same as USOC and as T568. Pair number 2 just surrounds pair number 1. It just goes outwards. So that's orange. See here? So here's pair 1, here and here, and there's pair 2 here and here. It just goes outwards. And when it comes to counting the pairs in the USOC configuration, you just go 1, 2, 3, and 4. Just keep going outwards. So that's the USOC configuration. When it comes to T568, which will be the data wires configuration, the pairs are counted a little bit different. And this is always, every year I do a little dance, and maybe somebody's going to write the music to it, or maybe not. So it's pair 1, pair 2, pair 3, and pair 4. Okay, 1, 2, 3, 4. All right? So blue, orange, green, brown. Okay? Instead of blue, orange, green, brown for USOG, for T568, blue, orange, green, and brown. So here's my dance as far as, and of course, that's the A configuration right here. Right? If you're talking about B configuration, you just switch the greens and the oranges. So it's going to be blue, green, orange, and brown. So that's the B configuration. Now, when you're talking about making a cross connect cable, then you're switching the configurations. On one side, you're going to have one configuration, and on the other side, you're going to have another configuration. So if it's A on one side and B on the other side, you're having a crossover link. So the oranges and greens are being switched. The reason for that is that when it comes to Cat5A, right? Sorry, Cat5E, not A. Cat6 is A. All right, so Cat5E, the only two pairs are being used are orange and green. The blue and brown are not used. They still have to be connected, they still have to be terminated, but they are not used in the Cat5E type of configuration. How are they being used? One is transmit and one is receive. So on one pair, the communication goes one way, and the other pair, the communication goes the other way. Which one is transmit and which one is receive? Well, that depends on which end of the cable you're looking at. Right? You're looking for this one here, it's going to communication is going this way. You're looking the other way, the communication is going to go the other way. So one is transmit, one is receive. So I said that last time when we were talking, actually yesterday. Sometimes it helps you to know that. Right? Like for example, I had a situation years ago when I was connecting security cameras for the client. And they wanted me to use, in order to save money, they wanted me to use some of the existing Cat5e wiring that was in the building, and maybe some and add some more wiring where additional cameras were supposed to go. So I get my tester and I test the existing links just to make sure that there's no any breaks in the wires and do they fill the specifications. So can I have those on? And one of the cable runs was long and it was awkward. It was an industrial environment, so it was very difficult to re-pull another wire. Yes, everything is possible, but at what price and how much time am I going to spend on it? But this one was a really difficult run to accomplish. And I noticed that when I put the tester on, the link failed. And I look at my screens, test screens, and just say, okay, what is it that failed? Is it the distance? Is it the wire is broken or what? It turned out that one of the pairs had a break in it. Right? One of the conductors was basically open, was pretty much cut somewhere. Right? So I'm looking at that and I go, well, let's see which pairs they are. And it was one of the brown pair. It was one of the conductors of the brown pair. So even though the link failed, but because I knew that in Cat5e communication, we're only using orange and green, so I said, yes, well, this cable, even though it failed as a Cat5e certification, it's still going to work in this case, because in Cat5e, we're only using orange and green. So I said it to the client, look, this is the situation. Technically, we should pull another wire, but it's your call. The client is our master in some cases, right? When it comes to compromising the safety, then no, you're responsible for the installation that is safe. But when it comes to this, it was the client's call. So it's going to cost you this much extra for me to pull another wire, but it's still going to work. Now, I don't know where the break is and how severe that is. Are the other pairs compromised? Who knows? But right now it works, so it's your call. So the client wanted to keep that way. So that was it. But that sort of conversation involves some sort of a knowledge. If you didn't know, you would just say, no, we need to re-pull the cable, and that would be it. Okay, so when it comes to the pinout for the T568 standard, here's the first pair, here's the second pair, here is the third pair, and here is the fourth pair. So blue, orange, green, and brown. Remember? Blue, orange, green, and brown for A. Now, for B, you just switch the greens and oranges. Now, when you Google a crossover link, and by the way, pretty much almost, I would say pretty much 100% of the links that you're going to install, which would be the permanent links, permanently installed links, which will be jack in the wall to the port at the patch panel, they are all going to be straight links. So either A to A or B to B, it doesn't matter, right? As long as you keep the same configuration. Now, when it comes to making or preparing or using patch cables that, those Ethernet cables that have Ethernet plug on one end and Ethernet plug on the other one. So you're using them to plug in the port on the patch panel to the port of the whatever other equipment. Usually it would be a switch or a modem or something else. But switch would be the usual thing that you're using that. Sometimes when you have to connect two switches together, it is required for you to use the crossover patch cable. So that's the only reason why you would have to have, well, not the only reason, because if for any reason you want to connect two computers, right, then you would have to use a crossover cable. Simply because, okay, the network interface card has an RJ45 jack in it. And it's wired in such a way that the transmit pair is in certain place physically and the receive pair is placed in certain place physically on that jack. That's, physically it's made the same, but this is how it internally it's connected. Now, when you're connecting that, running a straight link into a switch, could be through a patch panel, which is straight link again, and then you're connecting it to a switch, port on a switch, that port is wired in the opposite way. So you're connecting a transmit pair into a receive pair on the other end. So you're using a straight link. But if you have two pieces of equipment that are the same, if you, for any reason, you want to connect one PC to another, well, they have those jacks that are wired the same way. And if you use a straight link patch cable, you're going to connect transmit pair from one into a transmit pair from the other one. They won't talk. And you're going to connect receive pair to a receive pair to another one. Then the communication is not going to happen. What you need to do is you need to connect the transmit pair from one side into a receive pair on the other side, and same the other way. Okay, so then you have to use a crossover cable because of that. So now we are switching green and orange pairs for the crossover, and that only works for Cat5e. Because in Cat5e, only two pairs are being used. So we are leaving the other pairs alone, unswitched, which would be the blue pair and the brown pair. So when you Google the crossover link and you call up some images, you're going to see two versions. And they're going to be completely different, quite different when it comes to wiring. And they're both are going to be called crossover links. What you're going to find is, in some cases, you're going to see an image of crossover link when you see the orange and the greens are switched, and it's going to be called crossover link. And in some images, you're going to see that oranges and greens are being switched, and also blues and browns are also going to be switched around. And that also is going to be called a crossover link. And you're going to go, what is going on? This or that? This is called crossover link, and that is called crossover link. But obviously, the wiring is kind of like, what's going on? Yeah, okay, well, here I will tell you. Okay, I'm going to solve the mystery for you. When it comes to Cat6, category 6 cable, and up, then all four pairs are being used. In Cat5e, just the green and orange pair are being used. In Cat6 and up, you're going to see that the blues and browns are also being used to transmit signal. So if you're going to make a crossover cable, which involves Cat6, you also have to switch the other pairs because they're being used at this time, right? So you not only have to switch oranges and greens, you also have to switch blues and browns. Okay, so here's a mystery solved. What do we see here? You can see further on the table, I'm not sure if you can see it or not, I'm just going to zoom it in a little bit. Like, for example, the blue pair in Cat5e, see, that is not connected. All right. Let's see the brown pair. Also says not connected. But if you were Cat6, it would be connected. Let's look at the Cat5e. Blue pair, so orange pair. All right. It's listed as transmission data or receive data or data. Okay, so here's a pair for Cat6, Cat5e A. So here's the green white or the stripe would be transmission data plus, and the solid green would be transmission data minus, which would translate into a tip and ring. And the green or the oranges over here will be receive data as a tip, receive data positive, and here we go here, receive data negative, so we also have a tip and ring. We got here tip, orange, and ring here. So that's how you look at this table here. Now, this is what I said. Sometimes you're going to see less expensive patch cables that are going to be labeled as Cat5e. And quite often, in some of the less expensive cables, you're not going to even see the brown and the blue. You're just going to see the orange and green, and that's it, because that's all you need. That's how they save money on producing those. And that's a Cat5e, straight link. And what do we see here? Here's a NIC, MDI, and here is a hub or a switch, MDI. NIC is a network interface card, which would be the jack on your PC. In some of the older PCs, of the desktop PCs, it used to be a card actually that you put in the card slot, and it would have the jack in it, right? So that's why it's called network interface card. Now these days, most of the network interface cards are basically built in to the motherboard, right? So MDI stands for medium dependent interface. It's a mouthful, but it's a very complicated and complicated way of saying that it is a box that that's being used as an interface. Medium dependent. Well, what is the medium that is being used? In our case, the medium for the signal to travel through is the wire, is the copper wiring. But it doesn't have to be copper always. It could be optical fiber, it could be fiber optics, okay? Or it could be air, which would be the wireless or Wi-Fi kind of an interface. So that's what's a, generally speaking, medium dependent interface, because it's an interface that is supposed to interface that piece of equipment, whatever it's working with, to another interface box that is working with another piece of equipment, and that interface it depends on the medium, because if there is no medium connecting these two interfaces, those interfaces are basically a boat anchor. It's not they're useless. Right, so on NIC, this would be usually at the PC side, and this would be usually, well, usually this would be at the receiving, or not the receiving end. This would be at the central location, which would be the LAN room. Right. So how do we look at those transmit and receive? At the NIC interface or network interface card, medium interface, medium dependent interface, so NIC NDI, all right. The green would be transmit. This is the A configuration. And on the other side, on the switchboard, this would be a receive pair. And of course, the orange at the NIC would be a receive pair here. And on the other side, this will be a transmit. So you connect transmit on one end to receive on the other end, and you can connect the receive on one end to transmit on it. That's how communications happen. You know? One is talking, the other one is listening. That's how communication is happening. Right? So that's the Cat5e. That will be a straight link. And over here, see that? Oh, cool. I can do this. Now, this would be a crossover. If you connect two NICs, two network interface cards, which would be one PC to another PC, for example. Or sometimes you're going to connect one switch to another. So they work together. And sometimes you're required to use crossover cable to connect two switches together. So you end up with more ports. So the switches communicate with each other and they act like one big switch. Right? However, now these days, you're going to find that a lot of that modern equipment, the switches, they have automatic sensing. So it doesn't matter which cable you use, either straight link or crossover, the two interfaces are going to do a little magic dance and then going to figure out which pairs are transmit, which you receive, and then they're going to lock on to the state. If you plug in a straight cable, it's going to do a little kind of a dance, and it's going to say, oh, okay, we have a straight link cable connected, so this is how we're going to configure ourselves to talk to each other. Or if you have a crossover cable, it's automatic sensing. However, still you're going to find some of the older equipment that doesn't have that automatic sensing. So it's just so you know. Right? All right, now how does that translate into stuff that we have already done? Remember this configuration here when we did the crossover link, and I asked you to do a crossover Ethernet 2 jacks, which usually you will not do, but I wanted you to experience have the experience of using the crossover link. And I didn't want you to make, on the next lab, I didn't want you to make a crossover patch cable, because you get to keep that patch cable, and most of the stuff that you're going to use at your home, it involves a straight link. So I wanted you to make the straight link for the patch cable, so you could actually use it at home when you take it home. Right? So that's why I asked you to do the crossover link at the punch down jacks. And we tested them, and the test failed because the tester was looking for a straight link. So it says, yeah, it failed a straight link, and we had to switch to another screen, go step up into a screen to see how it failed, and we were looking at the wire mapping, and this would be the wire mapping for a crossover link, which translates into this, which translates into that. So that's why I said we're going to analyze it on one of the lectures. Okay? Now, when it comes to T568 crossover cable for Cat6 and up, you're not only switching oranges and the greens. See here, orange and green here, and the green, orange and green here. We're also switching the browns and the blues and the browns and the blues. So that's where you're going to see, sometimes you're going to see that as a crossover, well, if you Google that. But this would be a crossover cable that is fulfilling the specifications of Cat6 and up. So be Cat6A, and A stands for amended, E stands for enhanced, so Cat5, Cat5E, so Cat5E, which the E stands for enhanced. And then there's Cat6, and there's Cat6A, as in A, as in apple, or as an alpha, and it stands for amended. I always keep forgetting that word, but today I remembered, right? And that amended stands basically for enhanced, right? Right, so that's the one. That's the. I just didn't want to rush through that because we had to cover some of that, and I wanted you to have a full understanding of this. So it's better to slow down a little bit and explain this thing to you, so you understand it better. Okay, I just keep talking, feeling the space with the sound. All right, so here is another topic that we're going to cover. The reason why I'm showing you this is when it comes to infrastructure systems industry, which basically is a cabling industry. It's not only, although it's a huge part of the business, is that somebody is going to call you and contract you into properly installing a network cabling system. And you can make a career out of that, and you can make lots of money, and you'll live happily ever after if you learn how to pull the wires properly and terminate them properly at each end in a way that it is reliable type of a link system. And you can make lots of money doing that. Lots. Yeah, you can make some considerable amount of money. And it's a huge part of the business. However, sometimes, well, quite often, as a technician, as a cable technician, you are going to be required to install systems. Like, for example, you could be hired by a company who does a lot of school PA systems. So you have to know how the school PA system works. Part of that, the PA system lab that we did, the distributed audio, that's a huge chunk of it. If you understand how that distributed audio works, this is not connecting a stereo system in your living room. Right? You can do it for your girlfriend or for your boyfriend and impress them. Good. But what you get paid for is, and you can make your career in that industry, is installing that the audio system in a way that that I showed you, the audio distributed system or distributed audio system. So this is part of that. So some of the companies, and you have to learn how the system works, because these days this is not just some kind of an amplifier connected to a bunch of speakers. Yeah, okay, but there's some other interfaces, other pieces of equipment that are pretty much computer based. They're smart devices. They're connected to the networks. They're networkable. Right? So you're going to have to learn how to install some of those systems. Some of the companies that you might get hired, do a lot of security alarms or security cameras or something that's called a nurse call systems. A nurse call system is a system that when you're in bed, hopefully you're not, in the hospital, and the nurses give you that little button to call for help if you need. Okay, so that is not just a wire that is running there and there's some sort of a light bulb at the reception desk. No, it goes to a smart system, computerized system that distributes that call, and it can be programmed, and they get this indication of which room, which bed, and there's a light on the corridor light right above the room that is, and all that stuff. It's all computerized, and some of the nurse call systems, they have pagers or phones that are being interfaced with them. So if there's a nurse walking around and she's got a pager, then some patient calls and she's got a page that, okay, a patient calls from room so-and-so, all right, things like that. Right? So all those systems are programmable. They're phone systems, they are intercom systems, they're fire alarm systems, which you require additional licensing for, and climate control systems and whatnot. All of them require Ethernet. Most of the systems, if not all by now, are Ethernet based. So if you absolutely have to know how to connect the Ethernet links. That's why I spent so much time showing you how to connect the RG45 registered jack in a straight configuration, in the crossover configuration. We spent some time connecting the patch cords. Next lab, we're going to spend connecting patch panels. All right. So I'm just giving you that information. So that's all the infrastructure. But quite often you're going to be required to install systems, retail systems. You're going to connect a bunch of registers, cash registers, POS, which stands point of sale. One of the meanings, at least. So in each system, in each situation, you're going to have to learn the system. How do you learn how to install the system? Well, first, one way of doing that is being sent with somebody else who already knows how to do that. And they're going to walk you in through it, and before you know it, you're going to know how to do it yourself. Other ways of learning how the systems work is that these systems are not being sold by manufacturer straight. The companies who install those systems, they don't buy them straight from the manufacturers. They buy them from distribution companies, and the distribution company would be carrying many different brands. Like they could be carrying a Paradox for security, or they could be carrying DSC for security. They could be carrying Edwards or Edcom for PA systems. They could be carrying some, Edwards also for the alarm systems, and there will be other fire alarm systems as well. So they are distribution companies. What happens? They are in the good relationships with the home automation systems or home theater systems or whatnot. All right, they're in relationships with the manufacturers. Those distribution companies, they get the equipment from the manufacturer, and the companies who install that, they have a relationship with the distribution companies. So what happens with the distribution companies? They have a database of all the people who are registered. They don't sell it to public. You have to have a registered business, and you have to be in business in order to be able to go to that store and buy that stuff, right? Which is not hard to do. You have to register business and HST, and you just go and register with them. You have an account. You have a cash and carry account, or you can have a credited account. Right? Now, so what happens is that those distribution companies, they organize training. If there's a new system coming out, or maybe sometimes it's not a new system, but periodically the representatives from the companies who sell the equipment, they schedule training sessions at the facilities of the distribution company. They have a huge conference room, and they will send emails to all the clients, which would be the clients who are the installers. They say, okay, date so-and-so, 2 months from now, there will be a rep from so-and-so, and they're going to have a seminar on so-and-so system. Right? Please register. And a lot of people do. So sometimes if you're in business on your own, you can register for that, and you're going to spend a day, sometimes 2 or 3, at the training session at the facility where the company rep comes and presents some sort of a system, and they talk about how this thing is being organized, how to install it, how to program it, and you get some hands-on practice as well. So that's how those things work, and they will fill you up with coffee and donuts and sandwiches and whatnot, and you're going to spend the whole day. So you're not just on your own after you leave the school, because your self-education happens all the time, because there are new systems coming up all the time. Plus, new people are being hired, and the existing systems, they also have to be trained on systems. So that's how the training happens. Okay. All right. So let's just take a look, and maybe we're going to have some time just to go through the security alarms. Right. This is a main board of one of the popular security alarm system. Okay. Now they have terminals, and we're just going to go over how the security system works. I'm just going to go one by one, explain some of the idea. I'm not going to go into details, because I can just give you the basic idea of in general, how security system works, security alarm. But the details, the way things are organized, as far as connections, as far as programming structure, and so on, they vary from brand to brand. There's not only one brand for security alarm. There are many brands. And of course, a lot of them are password protected and so on. So you have to be in the industry to know more. But I'll give you the basic idea how it works, so you know what they're talking about. I'm going to give you enough information. So if you go to a proper, this is proper too. If you go to a specific training on a specific brand and a specific model of equipment, after what I talk to you about, what I show you, you will actually be able to be trained. So because you will know what they're talking about when they're training you. Right? So, so let's just analyze this main board here. Okay? We're going to analyze connections. So we're going to go straight from here, from left all the way to the right, and we're going to analyze some connections. Come on, wrong way. All right, so this is this part here, which is that connector right there. All right, so the first two prongs, or the first two terminals, it is AC. It's called AC. What do you connect to that? Usually, it's like a doorbell transformer. It could be wired in transformer that you wire into a electrical panel, and you have the terminals with 18 volts AC. It's just a straight transformer that, or you can have a power supply that you plug in to the outlet, and on the other side you have two screw terminals with 18 volts AC, and that's where you plug it in to power up this whole thing. That's where the power gets from. Right? The next two terminals, they're called bell. Right? That is the siren. When the alarm trips, it has to make noise. Well, how does the device, the noise-making device, know that it's supposed to make noise? Well, because on those terminals, those bell terminals, plus and minus, you're going to have 12 volts DC appearing on that. And when the siren, there will be a 30-watt siren or 15-watt siren, or maybe a strobe light, or maybe both. Some of the devices have strobe light and a siren. They're very annoying and loud. Once they have the 12 volts supplied to them, that's how they basically work. They make loud noise. All right, now, program terminals, they are programmable terminals. Usually it would be, sometimes you're going to have a dry contact relay appearing on those, and that thing could be programmed into closing or opening based on whatever condition, whether the system is armed, it's going to behave a certain way, or whether the system is disarmed, it's going to behave a certain way, or if the system goes into alarm condition, it's going to behave a certain way, or whatever other conditions there could be. They're programmable. So some of them could be relays, dry contact relays, basically switches that close, and they can operate other things that are power supplied with power, or they could be supplying voltage. So like, for example, if the program triggers, there could be 12 volts appearing on number one based on some condition, and that program terminal can be programmed to act certain way. And the individual program terminals can be programmed, each individual, to have a specific function. How do they work? Are they just relay contacts, or do they have 12 volts happening onto them? Well, it depends on the system, so you just have to read the documentation on that particular model or the brand, or you're going to call the support, technical support, and you can ask. Then this one, so in this case, this would be 12 volt appearing on these. Or sometimes they could be that the terminal, it's a free floating terminal, and it connects to ground, depends on some conditions. It's all in the documentation, different systems work in a different way. Then you have a relay contact here, right? So there's a common for the relay, and is normally open, normally closed. So it's basically a single pole double throw switch that operates as a relay. And what's a relay? It's a switch that can be triggered by supplying power to the electromagnet that is connected to it. Right? If you want to know more about relay, well, if you don't know already, talk to me in class and I'll explain it to you. And if you don't want to talk to me in class so I can explain it to you, Google it or YouTube it. So that would be the first terminal that we have here on that. Let's keep moving. See here, that's this one right here, right now, auxiliary and a bus. Right? So auxiliary, it shows plus and minus. Right? So what happens, this is the terminal that provides 12 volt DC power to all the active devices. What will be active devices? First of all, what is a passive device? A passive device is a device that does not require any power to operate. an example of a passive device in security alarm system, industry would be a door contact switch. A door contact involves something that's called a reed switch. If anybody plays clarinet or saxophone, the mouthpiece is connected to a reed, and the reed basically is two flat pieces of something that when you pass the air through it, they vibrate. So it looks like a reed. So the switch looks like this. And when you bring a magnet close to it, they close. So that's why it's called reed switch. So the reed switch, that it doesn't require power to operate. It just requires a magnet to be brought in close proximity in order for that to operate. So that's all. And those are being mounted. So the switch could be mounted on the door frame, and the magnet could be mounted on the door itself. So when the door opens, the magnet goes away from it, the switch opens. When the door closes, the magnet goes close proximity with the switch closes. It's a passive device. Right? Now, when it comes to something like a motion sensor, a motion sensor is a device that requires power to operate. It is going to give you open or close contact, but based on some condition. You need to have some sort of electronic circuitry to sense the motion in the room or in close proximity to it. Usually you have the motion sensors inside the room. It's very rarely you're going to have motion sensors mounted on the outside because there's a motion happening all the time. There are animals walking, birds flying, and whatnot. How the motion sensors work, they have different ways of sensing them. One of them is sensing the infrared energy. We all have body heat. We emit the infrared energy, and the motion sensor sees that. It has an infrared sensor, and it sees that energy, and it's still not going to trigger, but that energy has to move from one place to another. So if there's a change in that, then the motion sensor triggers. Right? So that involves electronic circuitry to operate, and the power has to be supplied to it. So that's why we have those auxiliary terminals that they supply 12-volt DC to all the active devices. And what would be another example of active device in a security alarm system? One of the examples would be, well, motion sensor. The other one would be a glass break detector. Okay? Another one would be heat detector, smoke detector, and so on. That's pretty much. There's some other ones as well. Okay? But most of the time with motion sensor, glass break detector. What would be other active devices that are not sensors? Well, an active device would be a keypad. A keypad also it has electronic circuitry that needs to be powered. Right? So the power has to be supplied. It all comes from here. What other device would be? An expansion board. Like if you have a security system that is capable of so many contact points, which are called zones, that those contact points can be used to monitor a certain loop, which we'll talk about in a second. And if you need more zones, then you can get an expansion board, and that also has to be powered. So this is supplying the power to all the active devices. Okay? Now, right beside that, okay, how many devices can you put in? Well, you have to read the specs on the board to see how much current it is available from this terminal. How much current is available from this, because it can only supply so much current before it starts getting funny on you, all right? Which would be lowering the voltage, and things are happening that is not undesired things will be happening. So you have to read how much power this thing is able to provide, which will be the current capability or the ampacity of it. And you have to read the current draw on every device that you plug into that. And all the current draws by all the devices altogether, they cannot exceed the ampacity or the capability of the current being supplied from this. If you need more devices that exceed the total power that is being supplied to that, you need to get another expansion board that is not expanding the zones, but basically it's another power supply. Now here is the bus. Remember the bus topology? Huh? Green and yellow. So this would be using the Z type of cable, and Z cable is sometimes it's referred to as a security cable, right? But it's just a tiny, thin cable, 24 gauge, 22 gauge sometimes, and it just has 4 straight, untwisted conductors. And the colors would be red, green, black, and yellow. Right? So in this case, you would connect black and red as a power supply, and you would connect green and yellow as different, as something else. That something else would be, if it's a motion sensor, you would connect the red and black to the power supply into the motion sensor, and you would use the yellow and green as the signal wire. And the signal wire, basically, it's a closure. You close it, and the alarm system senses that the whole loop is closed, so everything is fine. You open it, that means the zone is open. Right? If it's armed, it's going to trigger an alarm. If it's not armed, it's going to say that the door is open. Right? And usually the green would be connected to the ground, and the yellow will be connected to not ground, the other terminal. But if it's a bus configuration, if that cable is connected not to a sensor, but if the cable is connected to a keypad, then you would connect the data line. This is where the data communication happens from the keypad. And you can connect multiple keypads, and they're going to use the same bus pair to communicate with the main board. How they communicate? They do their magic by just using the just one pair. And you can also connect other things like expansion board data to the bus, and they're going to say bus on the other side, right? So that's what these are for, right? Now we're going to move further to the right. You have common, which was the same point, right? It's basically a ground, but it's called common here, our system ground. And there's Z1, 2, 3, 4, 5, 6, 7, 8. So this board is capable, as it is, of 8 zones. What is a zone? It's a circuit. To the main board, zone 1 is a circuit. If the circuit is shorted, which is connected right to the common, then the system is at rest. If the zone is open, which is disconnected from the common, then there's a condition. Let's say the door is open, or there's a motion happening. Right? And if the loop is open, if the system is armed, well, it can go into it can trigger into alarm. If it's not armed, it's just going to maybe indicate on the keypad that the door is open, or the window is open, or there's a motion in something like that. Right? And you can have zone 1 to have all the motion sensors in the living room connected in a series configuration. So if one of them opens, the whole zone is broken. Zone number 2, it could be connected to all the windows in the living room in series, from one window to another, to another, to another. If one window opens, the whole loop is broken, and there's a condition, right? And so on. So you can have 8 zones on that. And sometimes when you install the security alarms, you combine the devices in series in order to utilize, to save up the zones. And you're going to do it in a way that makes sense. Right? So and the commons are so basically that's the zones, right? There's a serial communication happening there. There's a terminal that's a serial, right? So that's where you connect the serial interface, which can connect to your laptop, so you can program the system. Or sometimes the serial interface is connected into something that's called the IT interface, which would be the digital interface, which would enable you to connect the system into your LAN network, local area network, into a switch. It has the serial interface has connector that connects to that, and on the other side of that box of a serial interface, there's an RJ45 jack. that you just plug in Ethernet cable and connect that to a switch. Also, there's a terminal that says battery. System has a battery, backup battery. That's where you connect the backup battery, and it's tendering the battery. What's tendering? It's basically keeping the charge all the time. When the system, when the power goes down, the system still works because it gets the power from the backup battery. How long is it going to last? We don't know. Anywhere from 1 hour to 2 hours, depending on how many active devices you have, how much current is being drawn through them. So it varies from system to system. And usually those batteries last 5-6 years and they have to be replaced. There's one terminal that I haven't showed you here, which would be here. You can see tip and ring. Some systems are being monitored. Some systems are being monitored through a POTS line. So that's where you connect the POTS line. When there's a POTS line coming into the house, you disconnect everything and you go to right to the demarcation point, which is the point of entry, right when the phone line enters the building, and you connect that to the tip and ring into the alarm system. And then you grab it from the tip and ring one and connect it to the rest of the house. The idea of that is that if there is an alarm, the system is going to steal the line from the rest of the house and is going to use it to communicate with the monitoring station. It's not communicating with the police station because police stations do not monitor alarms. They can respond to a call if somebody calls them, but they do not have facilities that are connected to individual alarms. The purpose of that purpose is being done. Oh, the purpose. That function is being done by something that's called monitoring stations, and they are businesses that are in business of monitoring alarms, security alarms, fire alarms, all kinds of other devices, but usually security and fire. Right? Some of the big companies, they don't have their own monitoring facilities. They use monitoring stations. Right? So the system steals the line, hangs it up. If somebody was on the phone, is going to cut you off, is going to hang up and pick it up, dial the number, communicate with the station, and hang up and release the line. And the station has received the signal. And depending on what the instructions are for this particular system, the personnel that is there 24/7, there are live people there, they're going to react in a certain way. How they're going to react? They're going to call police, or they're going to call you, or depending on whatever the instructions are. Right. So that's the communication thing here. All right. Backup battery. How many slides do we have? All right, if you have to go to another class, I'm just going to spend maybe 5 more minutes finishing up this slide because I don't want to carry it over. And if you want, I'm just going to post that thing anyways. So you're going to have a repeat from yesterday. Both of them are going to be posted, and you can just finish up watching it after it's being posted. Okay. So what do we have here? This is how the zones. You're welcome. This is how the zones are being wired. So this would be a door contact. Okay. Now the door contact can be mounted on the window. Okay. But for the general purpose, they're being called door contacts, sometimes DC. So here's the zone, and here's the door contact with a reed switch inside. If the magnet is getting close to it, it's going to close the switch. The zone is closed. The system is at rest. This particular zone is at rest. So that's one way of doing it. The other way of doing it is to have something that's called an end-of-line resistor. The zone can be programmed into looking for a certain type of resistance, certain value of a resistance, and then it's going to be at rest. If it is going to see a broken loop, then it's going to go into alarm. If it's going to go and see a dead short, and it's also going to go into a alarm. Right? So it's an extra security measure. That's one. Other thing is, in some cases, the zones can be doubled. So you could have a physical board which is capable of 8 zones. but it can be made into a 16-zone board because you can double them up. You can have a bunch of devices. It has to be programmed that way, right? A bunch of devices connected in without the end-of-line resistors, so that would be considered as zone number 1. And you can have another same screw terminals for that zone could be connected with the end-of-line resistors. And it's going to sense what is going to happen, and based on what happens, it's going to react in a certain way. Right? So that can also be done. Right? So that's how the devices are, the passive devices are being connected. Here's an active device. Good example of active device would be a motion sensor. If you take the cover off, you're going to see the infrared sensor here. And over here, this looks like a piece of plastic cover, but it's actually a lens, like a photography lens, but it's not, designed for a human eye. It's designed for the infrared eye. And it shapes those infrared beams and return beams, reflections, in a certain way. So the lens should be on. The cover also has the lens in it. So it shapes the infrared beam a certain way. Sometimes those transmit the infrared and see the return, and sometimes they just see. So this one is just looks at it, right, in the infrared. Now, if you look at the screw terminals, here is a blow-up version here. And what do you see? Oh, look at that. That's where you connect the power. This will be positive, negative, and it actually says on this particular one it needs 12 volt and ground, so that's a DC. And you would use the red and black cable conductors, red and black pair, to connect the power. And then the red and black goes into the auxiliary output or the auxiliary terminal on the main board. And then here is the relay. One is common, so that's common. And here's normally closed or normally open. So when the system is at rest, the normally closed is closed. There is a short here. If the system goes into a condition, then the relay switches. This becomes closed and this becomes open. So the loop is open, system reacts. Right? So that's basically how that works. Now, not yet. The way I talked about before, how do we combine zones? You can have one zone. If you're going to connect every single device as per its individual zone, you're going to run out of zones very quickly. So like, for example, if you have in the living room or in the bedroom or somewhere, you have 3 windows on one wall. Then you can just series them together and connect them to one of the zones. And you could just label that as living room windows. As soon as one of them opens, the whole loop is broken and the system goes into a condition. You can also daisy chain those motion sensors as well, from one to another, right here. From one, okay, so from one here, okay, no, this is the yellow. From one to another, to another, to another, to another, and then come back into the and connect it into a zone. Of course, the power is going to be connected in parallel because you just have to connect them. You can't daisy chain power, but the signal will be connected in series just in this sort of configuration. Right? And where are we? All right, the cable that is the cable that is being used is a Z type of cable. That's what it looks like. It's a tin. They come in white, brown, sometimes different colors, but usually white or brown. Right? Sometimes some sort of like a rosy color too. Right? Jacketing. And it has 1, 2, 3, 4 conductors, so that's why this one is called Z4. And they are untwisted pair. And in security alarms, you don't want a twisted pair. When it comes to data, you want twisted pair because to eliminate the crosstalk and the possibility of interference and so on. In the alarm system, you want an untwisted pair, just the straight wires. The reason for that is that if you have a twisted pair, the twist in that pair has inductive properties, so it has properties of a coil. And if you remember, maybe with me or some other subjects, you were talking about how the coils like change. Capacitors like change. They love change. They will pass the change through. Coils or inductors do not like change. They will not pass the change through. If there's a sudden change, a coil is going to oppose. And the more sudden and drastic the change is, the more sudden and drastic the response is going to be by the coil. So here's the situation. If you open and close the door very fast, and if the wire is long enough and if it was twisted, the pair, then that quick opening and closing of the door, the signal might not even get to the security panel, right, to the zone. If you open it and leave it open, then yes, finally that there's a sudden change, but then after the change there is no change, then yes, it's going to pass that through. But that's the reason why we need the untwisted pair for the security alarms. And so Z4 is going to have 4 conductors. It could be Z8 or Z16. Z8 will be having 8 conductors. Z16 will be having 16 conductors. Now we're just going to go through some of the, thank you guys. We're going to go through the sensors. The sensors that are in the security alarms, the motion sensors, door contacts, glass break sensors. How do the glass break sensors work? The glass break sensors work in a way that when there's a window that breaks, there are 3 things that happen in the room. There is that high-pitched sound of glass breaking, so that's one. There's also the low-frequency rumble of the rumble before the break, so that has to be present. And there's a sudden pressure change. Those 3 conditions are present, the glass break detector is going to react. The reason for that is that 3 things have to be present, is so there are no false alarms. If there's a cat walking on the countertop and the cat drops the glass on the floor, you're going to have the high frequency sound of the glass breaking, but you're not going to have the low frequency rumble of the window just before it breaks, and you're not going to have a sudden pressure change, no alarm, and rightfully so. You don't want the false alarms, because false alarms are bad. But also, if there is a lightning outside, the windows might rumble a little bit, but there's no that high frequency pitch of glass breaking, and there's no sudden pressure change inside the room because the windows are still closed. Okay, so that's how the glass break works. Smoke detectors, they detect smoke. Heat detectors, they detect heat. Smoke detectors are usually mounted on every level in every closed room, depending on the codes that needs to. So the alarm system, security alarm system, can have certain fire alarm properties. And in some cases, in some areas or jurisdictions, it could be accepted as a part of a fire alarm. And the heat detector detects heat. So usually those are being mounted around the furnace rooms, because there's going to be fire first, and then there's a smoke and so on. So you want to detect heat. Water level detectors, usually will be the sump pumps detectors, and those zones, like for example, smoke, heat, and water level detectors, they will be connected to a specific zone on the security alarm, and that zone has to be programmed as 24/7 zone, which means the system does not have to be armed for that zone to be active. And that's good, because if there's a smoke, you don't want the smoke detector to act only when the system is armed. You want that smoke detector to be active all the time. Right? same as the water level detector in the heat on the sunk pump, or smoke or heat detector. Okay. Seismic detectors. These will be detectors that detect vibrations, and very popular use for those is in the banks, in the safes and stuff like that. So they could be placed around the safe surface or the vault. If somebody is trying to get to the safe by drilling or by, it's going to detect the vibrations and it's going to trigger an alarm. Panic buttons are very popular in retail situation. Variety stores, some other things, so, or offices with sensitive conversations. Around the countertops or whatever else, there could be a panic button. It's a silent alarm. Somebody presses the panic button, it's connected to the security alarm, it triggers a whole bunch of actions, right? And then the police show up out of nowhere, right? Well, they come from somewhere. And then those sensors, they could be wired or they could be wireless. There are wireless motion sensors. Very rarely you're going to see, I haven't seen one, a wireless glass break detector. I haven't seen one yet. I don't know why they don't produce them. There are also wireless door contacts. Sometimes it's difficult to run a cable. From hardwire is the best, but sometimes it's hard to wire. Like for example, if somebody calls you with a house, can you arm my house? Yes, you can. You arm your house. Oh, let me take a look at it. Oh, can you call me when you're painting? When is the next time you're going to paint? Because I might have to make some holes in the walls in order to pull the wires. Oh, we just painted. We just painted last month, and now we have a. Okay, well, you know what? Wireless. So you're gonna get the main panel. And you're going to mount wireless door contacts, wireless motions contacts, and so on. So it is possible to do that, just so you don't lose the business. And the wireless technology is gone quite far right now. That those wireless contacts are pretty darn good. Yeah. Annunciators, bell or the siren, strobe, or the system could be silent. Sometimes you don't want the burglar to know that the alarm has been triggered. Okay, so this alarm goes in, the system goes into alarm condition, but there's no indication whatsoever. And then the police show up out of nowhere. Okay, control devices would be keypads, laptops for programming, IP interfaces. So with the interface that connects to the serial port, and then the IP has the interface has the Ethernet jack, so it can be connected to a network. Remote access or wireless remote controls. Wireless remote controls are quite popular these days too. You can just go and go into your bedroom to have a good night's sleep, and you can have the remote control to arm the system. And you can arm it in the total arm. You can just completely arm it, fully arm the system. But sometimes when you're inside, you want to get into something that's called a stay arm, which stay arm would be programmed into a stay arm condition. You would include some of the zones, like the inside motion sensors, into a stay arm zones. So when the system is put into a stay arm instead of fully armed condition, then the outside parameter could be armed, but the inside motion sensors could be not armed. So in the middle of the night, if you go to the fridge to get a glass of milk, you're not triggering the alarm. But if somebody's trying to get it from outside, yes, they're going to trigger the alarm. So that's called the stay arm. So remote controls are quite popular, so you can just go to bed, click, arm the whole system, go to sleep, and then just have to remember to disarm it before you leave the house. And remote access, that's usually going through the IP because when you have the IP interface, that connects to your network. So your system is on a network. You can access that from outside, from your cell phone, from your laptop, tablet, or whatnot. Right? Interfacing. The alarm systems could be interfaced to access control, fire alarm, monitoring, and others. So access control. Access controls could be access control system could be a separate system, or it could be addition to the manufactured. Some brands have as accessories, you can have a whole door access or access control system. What's access control system? It's basically when you see sometimes those card readers in front of the doors, and sometimes we have to swipe the card to enter. That's access control. So it's popular, you see in our schools, we use it all the time. Also very popular in not retail, but real estate agencies. Just imagine you have one office that has so many offices and cubicles and whatnot, and there's just maybe 20 or something workstations there, because most of people work from home. But that agency, some of the agents need to go to the office to work on something or whatever. They use the facilities like printers and things like that. And they just have to go on the weekend, at night, whatever. Right? And that facility, that sales agency, that the real estate agency, let's say they hire 80 people. If there was no access control, every one of them would have to have a key cut so they can open the door. And it's a revolving door sometimes. People get hired, people leave to other agencies, whatnot. So if somebody leaves, then you're going to have to take the keys from everybody, change all the locks, and cut 80 keys for everybody else. And then maybe 3 days, same thing happens. So that will be just a pain in the neck. So what happens, the access controls are very popular because you just have the proximity readers or the proximity readers. So you just swipe the card or a fob. And then if somebody leaves, you just deactivate that key fob so it doesn't work with the system. Very popular thing. So the proximity reader, it can be interfaced to access control. That access control can be interfaced with the security alarm. So when you swipe the card, the system gets disarmed and the door strike is being released so you can enter the door. So this is a popular interfacing. Right? The system can be also, security system can be also configured with a fire alarm. Right? So let's say that there's remember that relay contact? So be an output. So based on, it could be programmed as a condition. If there's this alarm condition, close the relay. And that relay could be connected to one of the zones of the fire alarm. And the fire alarm can treat that as a condition. Right? It will be fire condition or something like that, right? So that monitoring, as I explained, systems are not getting monitored by the police. They're being monitored by something that's called monitoring stations. How do you make money on that? You can sign up with a monitoring station to be their associate. And they will give you a bunch of account numbers and whatnot, and they will train you on how to use their way of working, their system. And you get clients. They will like you, those monitoring stations. If you're installing alarm systems, they will like you because you're going to get more clients. More clients make money for them because the client pays you so much money per month for having the system monitored. Part of that money, a small part of that money, you pay to the monitoring station. You keep the rest. So the monitoring station is happy and you're happy because you get enough clients, you get enough residue income every month for having the system monitored. Right? So that's something to think about. Right? So that will be monitoring, and others will be others. Right? Okay. So passive devices or active devices. Door contacts. These include window contacts, overhead garage door contacts, surface mount, flash mount, sump pump contacts, and others. So be the passive devices that do not require power to operate. Active devices require power to operate. It will be keypads, expansion boards, motion sensors, glass break detectors, water sensors, and anything that requires power to operate will be active device. Okay. All right. So we're not going to go into the fire alarms. We're going to keep going the next time with that. So at least now you get the idea of how the security systems work, more or less. Okay. So as I said, the idea is you're not going to be able to install it right now from scratch. You will have to kind of train yourself a little bit more on it. But with this information that I'm giving you right now, you are at least ready to be trained. If there is a company that introduces a new system, they're going to talk the lingo, they're going to talk the way. You don't have to research the terminology because I just gave it to you. All right. Cool. All right. Thank you very much, guys. Wyatt, you stayed till the end. All right. Thank you, guys, and I will see you. I will see you when I see you. Thank you very much.